Have you ever just looked at one of these things just hanging in the air? It can flip, recover, and lock itself in place in the blink of an eye. And, it feels like magic, right? Like it's just defying gravity. But it's not. It's actually something far more interesting. See, that drone is in a constant, high-speed fight for its life.
So how does it actually do that? How does it stay so perfectly locked in place, even when a gust of wind comes along? You'd probably think it's just got some kind of incredible balance, right?
Well, here's the secret. It's not exactly balancing. In fact, a drone isn't really balancing at all. It's actually in a constant, high-speed battle to keep from falling out of the sky. And if you can understand that fight, you've got the key to the whole thing.
All right, so to really get what's happening here, we have to start with the basics, with the physics. And you know what? It's the same fundamental principle that keeps everything from a giant 747 to a tiny paper airplane in the sky.
And yep, it's this one, Newton's third law. It's a classic for a reason, right? So a drone's propellers, they're designed to do one thing really well, push a massive amount of air down. That's the action. And in return, the air pushes the drone up. That's your equal and opposite reaction. Simple as that. That's what gets it off the ground. So every single second a drone is airborne, it's in the middle of this constant four-way battle. You've got lift, which is the upward push fighting against the drone's own weight pulling it down. And then you have thrust, pushing it horizontally, fighting against drag, which is just air resistance trying to slow it down. The drone's entire flight is just a nonstop act of perfectly managing these four forces.
And you know that perfectly still hover we talked about? Well, there's a name for that, static equilibrium. It's this beautiful, perfect moment when the upward lift from the propellers exactly equals the downward pull of gravity. It looks so calm and peaceful, but underneath, the drone's brain is making thousands of tiny adjustments every single second just to hold that position.
Okay, and this right here, this is the crucial difference. What makes drones so wild? See, a plane is designed to be naturally stable. You can let go of the controls and it'll mostly fly straight. A drone is the complete opposite. It is inherently, fundamentally unstable. I mean, think of it like trying to balance a spinning plate on the tips of four pencils. Without a super-fast computer making constant, tiny corrections, it would just flip over and crash, instantly.
Okay, so how does it generate all the raw power it needs for this constant battle? It's time to get into the hardware that does all the heavy lifting. Let's talk about the muscle, the propulsion system.
Get this, just to hover, to stay completely still, the propellers on a typical drone are spinning at around 2,300 RPM. That is nearly 40 rotations every single second. To put that into perspective, that's actually faster than the main blades of most helicopters. So yeah, the motors making that happen have to be absolutely insane.
And this right here is the heart of that system, the brushless DC motor. Now the key word is brushless. In older motors, you had these little physical brushes that would make contact and wear down over time. Not here. It's all done electronically. And what that means is they're super efficient, they're incredibly responsive, and they last way, way longer. It's exactly why they're the absolute standard for any serious drone out there.
So how does it actually spin? Well, a signal comes into this tiny little component called an ESC. Think of it like a switchboard. It starts pulsing electricity through a set of coils, but in a very specific, perfect sequence. This creates a rotating magnetic field, which then literally pulls the motor's rotor around with it. It's this beautifully simple yet incredibly powerful process.
Okay, so having powerful muscles is awesome, but they're pretty much useless without a brain to tell them exactly what to do, right? So now we're going to get into the drone's nervous system.
And here it is. This is the flight controller, or FC for short. This is the literal brain of the whole operation. It's a circuit board that's constantly taking in data from all its sensors, and it's asking itself hundreds of times a second, am I level? Am I tilted? Am I drifting? And then, in a fraction of a second, it calculates exactly what needs to happen to fix any tiny error.
And remember that electronic speed controller, the ESC we just talked about? Well, it's the faithful enforcer. It's the bridge that connects the brain, the flight controller, to the muscle, the motor. It takes that tiny, low-power command from the brain and instantly translates it into the huge blast of high-power electricity the motor needs to change speed. It doesn't think, it doesn't ask questions, it just acts, instantly. So when you put it all together, you get this beautiful, lightning-fast chain of command. The pilot gives a command, the flight controller immediately does the math, it sends signals to the ESCs feed the right amount of power to the motors spin the propellers, and the drone moves. This whole conversation, from your thumb all the way to the propellers, happens so incredibly fast it feels instantaneous.
Okay, get ready for this. This next part, this is where it all comes together. We're about to uncover the simple, absolutely elegant secret that solves the drone's single biggest problem.
So think about it. You've got 4 powerful motors, all spinning like crazy. So why doesn't the whole drone just spin wildly out of control in the opposite direction? I mean, based on the physics we talked about, it should, right? It's a totally legitimate question. The answer is a force called torque. And this goes right back to Newton's third law. For every action, there's an equal and opposite reaction. So, when a motor spins a propeller clockwise, that's the action, the propeller tries to spin the entire drone's body counterclockwise. That's the reaction. And without a solution to this problem, a quadcopter would just be a useless, uncontrollable spinning top.
And the solution? Oh, it is so genius in its simplicity. All you do is spin 2 of the propellers clockwise, and you spin the other 2 counterclockwise. That's it. The rotational force, the torque, from one pair completely cancels out the torque from the other. The net result? 0 spin, just perfect, locked-in stability. It is absolutely brilliant.
And here's the cool part. By intentionally messing with that perfect balance for just a split second, the drone can move with incredible agility. It can rotate on the spot. We call that yaw. It can tilt forward and backward. That's pitch. And it can tilt side to side. That's roll. All of this incredible movement comes from tiny, precise changes in motor speed.
All right, so let's put this all together. Let's look at how these simple principles come together to create such precise, incredible control.
So this is basically the cheat sheet for how a drone flies. You want to go up? All 4 motors speed up together. You want to rotate or yaw? You just speed up one pair of motors and slow down the other to create that torque imbalance we talked about. To pitch forward, you speed up the back motors, which tilts it forward. And to roll to the right, you speed up the left motors. Every single complex movement you see is just a tiny variation of these simple rules.
So in the end, it really isn't magic. It's this incredible symphony of physics, electronics, and code all working together perfectly. And once you really see how all the pieces fit, you're just left with this deep appreciation for the absolutely brilliant engineering that lets these things dance in the sky. So I'll leave you with this final thought. We have pretty much perfected the flying camera. But what happens when this genius engineering becomes truly autonomous? When drones are no longer just tools that we control, but are independent agents navigating our world all on their own? That is the next frontier. And believe me, it's coming a lot faster than you might think.